Okay, so we have some more differentiations. The thing is, we're going to use what is called the chain rule. The chain rule is used when you have a composition of functions. In English, when you have a function inside of your function. So we have 4 examples here, all of which of increasing funness. Funness is a technical term. So for the first one here, your outside function would be x to the 4th. Your inside function would be 5x minus 7. So anytime you have a function in your function, you need to use the chain rule because you're differentiating a composition of functions. So the chain rule says the derivative of the outside with respect to the inside, so notationally it looks like this, where f is your outside and g is your inside, times the derivative of the inside. So I'll explain it 2 ways. You pick your favorite. I'll do the shortcut first. So the derivative of the outside, actually, you know what? I'm going to merge the techniques. The outside is x to the 4th, so the derivative of the outside would say you would bring the 4 in front, leave the inside alone, and take 1 off the exponent. So again, if your y was x to the 4th, then your y prime would be 4, bring the 4 in front, leave the x alone, take 1 off the exponent. Exact same thing here. But according to the chain rule, we're not done because we have to multiply by the derivative of the inside. What is the derivative of the inside? 5x minus 7 has a derivative of 5. Hooray! So again, chain rule, derivative of the outside. In this case, our outside was a power function. Bring the 4 in front, leave the inside alone, take 1 off, and then multiply by the derivative of the inside. The derivative of the inside is just 5. Now the comment is, we can clean this up a little bit. For instance, 4 times 5 in most countries is 20. And then we'll just copy down the 5x minus 7 cubed. Can I distribute through the 20, through the quantity, 5x minus 7? No. Why? Because Aunt Sally would beat down hardcore because exponents, the 3, before multiplication, the 20. So leave it alone, and it'll come home. There you go. Oh, there we go. Oh, that's nice. Woo! I don't know what that looks like. All right, part B, or baby. What's our outside? 7x squared. What's our inside? 2x cubed minus 9x. Okay, so if we had to, the derivative of the outside would be 14x, because you do 2 times a 7, leave the inside alone, take 1 off. Well, we're going to do the same thing here. 2 times a 7 makes 14. Leave the inside alone. Take 1 off the exponent. I'm just going to put a 1 there as a marker. You do not have to. But we're not done with the chain rule because we have to differentiate the inside. What is the derivative of the inside? 6x squared minus 9. Good. Now, unlike the previous one, here the exponent is a 1. So we could multiply the 14 all the way through and combine like terms. However, if it's not a 1, you got to leave it as is. I mean, you're more than welcome to FOIL it out. However, you don't want to. It's too much work, to be honest with you. So if we did multiply all this through, i.e., or what I should say is e.g., distribute the 14, and then FOIL from there, we would be getting 168 x to the 5th minus 1008 x cubed plus 1134x. Awesome. So again, depending on the problem, I might tell you, leave it alone after you're done differentiating. This one's not too bad because it's just a decent polynomial.